There it comes.
Incredible. Wow. How do you define consciousness?
It's a good question.
This is Aron Kisdi, and he is the founder of Autodiscovery, which is a humanoid and robotics business based here in the UK.
And we want to see more robots than people. We want to see a lot more robots in the world, and we think that can give society as a whole amazing benefits in the future.
Give us some idea of what it's like to work for the European Space Agency.
It's fantastic work.
He spent his time building the rovers that are roaming around Mars on exploration.
It can be dangerous if only a few companies or individuals or governments own most of the robotics.
Today he sat down and he brought his buddy with us, who's a G1 Unitree Humanoid. Nice to meet you. What's your view on third-party terrorists, hackers? Are we just creating a set of tools?
Maybe hackers hijack a robot, but defensive robot can respond to it much quicker.
What sort of stuff are they looking to manufacture in space?
Initially, they're looking at high-value items that are hard to make on Earth. One example can be
Amazing.
your brain discards the details that you don't need to know.
What are the things that worry you most about the scale, the speed, and the impact that these guys are going to have? Hey, buddy. That's fantastic. The two of you.
Yeah.
Okay. Does he have a name?
He does not have a name, but maybe you can name him during the podcast today.
We can. I'm going to put him on my side. Yeah, wandering around. That's a great idea. So we're recording around, yeah. Yeah, send him around. Sit him next to me. Yeah. That's such a good idea. Nice to meet you. I feel like he needs a name. It's incredible. You immediately feel some sense of, I don't know how to describe it.
Yeah, familiarity.
Familiarity, yeah, completely. That's so worrying. He's warm as well.
He is.
Which is also kind of weird as well, isn't it? Because that immediately makes him feel alive and kicking as well.
Yeah. The motors heating up is a feature, not a bug.
He's weighing in at, do you say
35 kilo, this one.
35 kg.
Can lift 2 kilo per arm.
Okay.
And then, of course, we have the full-size one, the H1, which is 185 centimeter tall.
Right. 55
to 70 kilo, depending on the model.
Yep.
And can lift 4 kilogram per arm, so you can really do stuff.
Do they have the same autonomous capabilities?
Yeah, so they share the kind of same compute and sensors,
right,
and same kind of software stack. So it's very easy to test something on the little guy and then immediately put the software on the big one.
Physically, you've got the same dexterity across.
They are slightly different configurations.
Right.
It's not quite like a scaled up version.
Right.
The big one has different type of joints, but we can easily translate the software, so it's not a major issue.
Incredible. Awesome. Do you want to send him back?
Yeah.
Then we can send him back and put him next to you. Go on, buddy. Aron, nice to meet you.
Nice to meet you too.
So this is a Unitree.
This is a Unitree G1 humanoid robot platform. We will, I think, talk about what that means. But we are the UK distributor for them, and this is going to a client today.
Mind-blowing. And what's incredible is that he walked here from your car.
Correct.
And there was quite a fuss, I believe.
Yeah, so many people on the street, taking photos and then interacting with me and the robot. It's incredible.
I mean, look, we've seen them all on YouTube, across social media, but to be sat here with him or her, however, this becomes an immediate dilemma, doesn't it? Immediately.
Absolutely.
What do I say?
Absolutely.
Is it a they?
Or an it?
An it?
Who knows?
Yeah, I know. I'm immediately we're into the kind of
consciousness discussion.
Consciousness discussion immediately. But to have one present with us is incredible. Thank you so much for bringing them along.
That is definitely what happened in recent times. Suddenly these devices are robust and affordable enough for everyone. So it's great time to start talking about how we can make use of this.
And this is your game.
It is, yeah, yeah. In fact, this is my robot, and he is going to the customer only as a stand-in for
Okay.
some time until they receive the new one, which has been delayed in shipping.
Do you actually find yourself growing attached? Because look, you've been in the
Yeah.
robotics industry forever, haven't you?
Yeah, yeah. I was definitely attached to some of the robots we built. They don't actually look this human. They were more a small toy car size tracked robot with an arm.
Right.
But we had them for over 10 years, and we took them to a lot of public events. And they all had their little personality of, we know that Bob, the arm sometimes go wrong, and Madge turns up a little bit slower. But we definitely got attached
Well,
to
do you know
those.
what? It's fascinating, isn't it? Because what I think about is that apparently like 75-80% of people that use ChatGPT
Yeah.
say please and thank
Mm.
you. And it's almost like they merge or respect that intelligence levels as if it's human. It's almost, I feel like it's a bit like that phantom limb syndrome. You know, when someone loses a limb, this thing, they've still got it. It's like that because they can feel that intelligence and sense it. I wonder if they sense it as human. And I wonder if that happens with these guys.
It definitely does already, even though currently that the movement is not that dexterous.
Yeah.
The main thing we have to say at events as a safety briefing is to tell people not to try to catch the robot in case it falls, because we all have this urge to go in and help him up, but we don't want people to accidentally pinch their fingers or something. So we let them know that if something happens, which is rarer and rarer, then just step out of the way, because we can fix the robot, but currently we can't fix people. So that's the only briefing we have to give, and that's because of this human urge of trying to help a fellow human when they stumble.
So where did it all begin, mate? Where did your fascination with robotics start?
Well, my fascination goes back to university times for me. I was involved with a society called Student Robotics at Southampton University. Since then, it grew, and it is still going. It is a society that does a competition every year for A-level students to build their own robots and to compete with their own robots. And it was a fantastic environment. And the very unique part of it is that those robots are not remote control. So the whole competition have to be autonomous.
Right.
So these quite young kids are building robots that they are not allowed to touch once the robots are in the arena. They have to press go and hope for the best. And of course, we get many hilarious and some very, very successful outcomes. So it was such a great experience that started the journey, and ever since I'm in robotics.
Yeah, absolutely. And that led you on to this fascinating stint, I believe, is it with the European Space Agency?
Yes, that's right. So I was working at RAL Space, which is part of UK government research. And we did multiple projects related to robotics, some of that within an ESA program called Seeker and Safer. And we were looking at the autonomous aspect of Mars rovers, see if we can have these robots navigate fully by themselves for long durations in missions.
And you were there for some time, I believe.
Yes, yeah, it was over 8 years. So it was, very, very good experience. I really enjoyed the time there.
Give us some idea of what it's like to work for the European Space Agency.
It's perhaps not as glamorous as people like to think, but it's fantastic work. You work with extremely smart people who are very knowledgeable in the technology. The quality is extremely high. But in terms of the technologies we use, we do need to rely on well-tested technologies, both in hardware and in software. Right. It's more important that things are robust than that things are high-performing. So with that in mind, sometimes the technologies we use in space are much older compared to some of the new devices that we are allowed to use here on Earth.
Really?
So something like this will take another 20, 30 years to get to the level of robustness. So we are even thinking about putting something like this in space.
Yeah, that makes sense. Based on the level of investment it takes to get off the ground, the last thing you need is something that inconsistent or doesn't perform when it gets there.
Absolutely. So that's the key. It's so difficult and expensive to, let's say, put something on the surface of Mars, is that you do want to spend the time, as much time as you can on Earth, to make sure that it's absolutely validated and it's going to work well and is going to complete the mission. That's why actually most missions tend to overperform even after the mission duration. Like Spirit and Opportunity, the mission duration was 6 months, and they went for many, many years, because they are designed to such a high standard that actually once it's there, it likely to overperform.
I did wonder that, actually, because that always seems the case, that these kind of space exploration editions, they, for a kind of very limited, initially a very limited kind of expedition, but they kind of go on forever, like 10x 20x their initial. So that's why it's because they build such robust systems and they're able to just continue.
We like to think if you would make a mobile phone to the same standards as space, you would have a 10-year-old phone, but it will never break. It will turn on instantaneously, and it will absolutely always do what you tell it to do.
Right, which is not always the case.
Which is not the case with modern technology.
And when you're at the ESG, what were the more interesting projects? What was your kind of most memorable projects that you worked on? Give us a flavor of that.
Definitely the Seeker one that I mentioned, which was looking at the long-range autonomy. And the reason we were trying to make the robot go further is because there are some places on Mars that are easy to land.
Right.
And there are some other places that are really interesting. And those are not the same places. So sometimes you're landing very far away from the points of interest. And to drive with remote control, which is how initially the missions were done, takes a very long time. The robots move very slowly. You're basically working around the clock in 2-day, 3-day shifts for the engineers to plan the next steps, to upload the mission, for the robot to move a few meters, then get the data back, and then plan the next step. So step by step, very slowly. If the robot is able to do a long-range navigation by itself, then it can get to those interesting places much quicker. And the goal of the European Mars rover, which is currently in storage, but hopefully will be launched sometime soon, is to look for rocks that are underground, more than 1.5 meters, 2 meters underground.
Okay.
That's interesting because rocks are old. Rocks give us heritage of the planet, both in terms of geology, but also in terms of biology. Mars doesn't have a magnetosphere like Earth. So nothing is protecting things on the surface from cosmic radiation. So we know that for life as we know it, it would be very hard to survive on the surface of Mars. But about 1.5 meters of the soil of Mars is protecting you from this radiation. So if we can go below that depth, we can see maybe some signs of what used to be on Mars in old times.
Yeah. Helping Elon work out, just how far he's going to need to dig in order to protect us from it.
If we have more data from that below 2 meters depth, we will learn much more about the history of the planet.
Amazing.
So these rocks are called an outcrop. So you see a little surface feature, but then it goes underground. So it's like an iceberg.
Okay.
But iceberg version of a rock. The task of our robot was to identify these. So the robot needs to go around and find the rocks that do go underground like this. So there's a lot of geology involved in the identification. And then find the drilling point where the rock is deep enough, but still reachable by the robot's drill.
Okay.
So it's quite challenging mission.
And you talk about how you land in one place, but you've got to get to another.
Yeah.
So what kind of distances, when you say they're a long way away, what kind of distances have they got to travel?
So we were doing about 6 kilometers a day,
right.
Which is definitely kind of state of the art, and getting to the point where the robot will be limited by the power systems rather than the capability of the navigation.
Do they use any of that radiation in order to provide the energy that's required to sort of repower these?
So the European mission is fully solar powered. That's by regulatory design. In ESA's mandate, we want the robot to have solar power instead of the NASA route, which is radiothermal generators. So radiation-based power source. It's because of that very beginning of the mission. So if something happens during the launch, you're still on Earth, something happens with the rocket and the rocket explodes, With solar panels, it's not a huge issue, but if you have a radiation source, you potentially can spread the radiation on Earth. So it's not about the end environment; it's about that very start of the journey, which is why this is a rule.
Yeah, it makes total sense. Yeah, and the biggest problem we have, I guess, with nuclear energy in itself, containing it on this planet and not being able to get rid of it somewhere universally.
Yeah.
So just talk to me about that experience then. So you're hands-on involved in designing and architecting the robots which were actually going to do the discovery work on Mars, on the planet.
So the robot itself is built in the UK by Airbus. The build is actually finished, and the robot is currently in storage waiting for launch. My project and team was actually looking a little bit ahead of the state of the art. So our software would be deployed on the robot after the initial mission is complete, to give it capabilities that exceed what the robot is currently capable of doing. So you can send a software update to a robot even on Mars.
Really?
Of course, you need to do this very carefully, and you generally only do it once you have achieved some of the initial goals. But our team was already looking at beyond the initial mission parameters and how can we make this robot even more capable.
Help me understand that bit. So how does that actually work? So look, I'm super interested in cosmology, but at a very, very minimal kind of level, right? Definitely a million miles away from an academic level. But from a practical perspective, so you're able to update software from here, but how do you get it from here to Mars?
We do have spacecraft around the orbit of Mars as well. So generally speaking, a communication like this would be relayed. It can go direct on occasions, but generally it goes via satellite orbiting Mars. And you sometimes have direct visibility. So it's same as on Earth. You sometimes have line of sight. You sometimes see the right part of Mars. Sometimes you don't. So you need to time the message. You may need to break it into pieces. And it takes a long time because even though the kind of light can reach the target on average about 8 to 10 minutes, the data volume that you need to upload, the bandwidth is much lower than our broadband internet. So you're back to like dial-up days of waiting for files to load and go up.
That's fascinating. Yeah. So is it using kind of traditional, I guess, evolved but traditional kind of satellite technology to do that?
Yes. Yeah. Again, space is quite traditional. We are using the things that are known to work and work very well. So it is traditional radio signals, similar to what we are using for communication satellites everywhere.
Wow. Well, you're the first guy that I've ever spoken to which actually been hands-on involved in anything like this, which is fascinating. Although I did go to school with a guy who was absolutely unbelievable. His name was Malcolm John, and he actually joined my lovely school down in Cornwall. Ended up joining CERN, as part of the initiatives there. He's an amazing guy.
Well, there's a spaceport now in Cornwall, so if he ever needs to go back, he has an interesting job location there as well.
He does, yes, yeah. So you've done the work with the European Space Agency, and then that's led you on to Autodiscovery, which is two things. One, is it your first entrepreneurial journey?
It is my first company, yes. Yeah.
Congrats.
Thank you.
Tell us a bit about it.
The reason why I started Autodiscovery is even during the space work, I started to get involved with more terrestrial robotic projects to see how the technology that we created for space exploration could be applied on Earth and benefit robots down here. The challenge that we had over and over again is that we build the hardware all the time for all these projects. You start from basic principles and build another robot and then program it. And then generally the project runs out before you get to the really cool stuff. When the software is getting more advanced and robust enough and you're starting to do the really interesting bits, your project ends. And then you start another project, you build another robot. So there was really this limitation of just having good, reliable hardware. So the goal of Autodiscovery was to find high quality, affordable platforms that people can develop the interesting applications on. That really accelerates the development. And that's why we have perhaps seen a very fast advances in humanoid robotics in the recent days. because platforms like the G1 here are suddenly very high quality and very affordable, which means even universities or small companies have the resources to purchase something like this, start playing with it, and start focusing on the really, really cool stuff. So we want to enable people to move quicker.
And when you talk about platforms, you're talking about the main businesses. So we've got, Optimus with Tesla, we've got Figure, we've got Unitree, the G1, and there's a number of other kind of main players. When you talk about platforms, it's the main players, or are you talking about the underlying technology that these are actually operating on?
Yeah. So when I say platform, I mean the kind of mechanical and electrical system that people build on top of. So definitely Unitree with G1 is a robot which I would call a platform. People can plug in new end effectors, new cameras, new software, new hands. All these upgrades can be made to tailor it to the application.
Right.
Say Tesla is a bit different because they do everything. So they build the robot, but they also build the software. So that's what I would consider a complete robot.
Yes.
But we are quite interested in platforms because it really opens up the possibility for everyone to play, really. Someone developed perhaps a really new type of camera. They don't need to build their own robot. They can get a platform and plug their instrument onto that to try it out, to bring it to market quicker.
Fascinating. And so what's the vision you've got at Autodiscovery? So I get where you're at. And so what is your personal vision is with Autodiscovery? Where do you see yourself and Autodiscovery contributing to the future of this?
Yeah. So we have kind of a really long-term vision that's the core of the company.
Brilliant.
Is just affordable, robust robots for everyone. And everyone is a really important word here. We really want to make sure that robots are available for anyone to purchase and own. We think that is an important part of future society. And in fact, it can be dangerous if only a few companies or individuals or governments own most of the robotics. So we want to make sure that robots remain accessible for everyone. So the affordability and everyone is a very key part of the mission. And we want to see more robots than people. We want to see a lot more robots in the world, and we think that can give society as a whole amazing benefits in the future.
Yes.
But in the short term, we are more a system integrator. So we using these platforms and our own developments, as well as some other people who we collaborate with, to create solutions so we can start putting useful robots in places where they can start doing useful things.
Yeah. And so that means I think you've got two areas, and you've got kind of the development. So you're developing, when you talk about it, you're developing your own components and your own infrastructure.
Yeah.
And then the second part is you're then also distributing.
Yes, that's right.
Talk us through that.
So, for example, if someone wants to build their own robot for an application, say picking eggs in a chicken farm, they can either decide to buy one of these platforms from us. We're a distributor. We can help them select the right components, and they can build their system on their own. They can add the tool that is needed to pick up the egg safely. They can add the camera system that allows them to find these eggs and all these other bits. And then they have their own product that they can sell to all the egg farmers. Now, the other route is if more an end user wants us to build this system, then we can do that integration work. We can bring together the components and build a system for them.
Right.
But we work with both kind of people, and we are only a very small company. Yes. The robotic market is huge, so collaboration is key. There's space for everyone.
To be clear about that, so if you were to, for example, have a customer that comes along and says, I want one of those G1s, I want it to pick eggs for me, collect eggs, and then we work out that it needs some other kind of feature or ancillary feature, for instance, softer hands or whatever it might be required.
Yeah.
You would then actually go away and then design and build that additional accessory that's required to mobilize a G1
do
to
this
meet
task.
that customer's requirements.
Correct. Yes.
Amazing.
And if it's not directly aligned with our immediate expertise, we would connect them up with someone who can.
You're already pioneering in a couple of areas. I think is it a hand and a 360 head?
Correct. So the two initial parts we focused on because we felt that those components are not advanced enough is the sensing technology, the cameras,
Right.
and the end effector, the hands. So we do have a very dexterous humanoid hand that is also affordable because that's a key part of our mission. That currently allows our larger humanoid to do highly dexterous tasks, same as a person. We are still working on the smaller version for this guy.
Okay, great. And just so when we talk about dexterous hands like a human, how dexterous are we talking here? What kind of things can it do?
So it's 14 actuated degrees of freedom. So we have 14 motors inside the hand. So there's no tendons, nothing in the forearm. It's all situated inside the hand. 14 means you can kind of splay your fingers as well. So you can touch the tip of any finger with your thumb. Still not quite as capable as the human hand. The human hand is amazing, but it's definitely more capable than some other simpler hands on the market, and more affordable than some of the even more refined hands.
You talk about that kind of the tendons and that. So there are people in this space which are going the kind of, I think it's named, is it exoskeletal kind of approach where they're looking to it looks to me, again, I'm several degrees away, but from the outside looking in, it looks like they're trying to mimic the kind of biology and the physiology of the human body.
Yes.
Is that a different route to this? Is that a different approach?
No, so this one is copying the capabilities of a human hand. Of course, we don't have artificial muscles. We have motors, but it's still kind of a 5-finger hand. Now the question is that the right tool for a job? It is definitely an easy tool for many jobs because our environment is designed for people, it's designed for hands. So we know how to do things with hands. It makes the programming, the approach much more straightforward. But for some tasks, like picking eggs, maybe it's much easier to have a soft end effector that can pick them up in a very simple, very robust way, rather than having all this dexterity that you're not using.
Yeah, so you're able to design it fit for purpose.
Yeah.
Wow, fantastic. Amazing. So just talk to us about where we are on this journey. So we see them all doing backflips on YouTube.
Yes.
And today, obviously, we've met your man here, which is incredible. Thank you so much for bringing them along. And right now, it's radio controlled.
Yes.
So just talk to us about where we are on this journey.
Most of the demonstrations that we see are remote control in one way or another, or partially remote controlled. The hardware is incredibly robust these days, which is fantastic that we can buy something so capable, something so robust at a price point where people can just get one and start playing. So that's incredible that happened basically this year, that people have access to these high quality robots. But there's a lot to do on the software. So right now, the autonomous capabilities of these systems are still very early days for these systems. The walking around is quite good.
You just walked down the street here.
Yeah.
Just arrived with a crowd.
I had so many people asking questions on the way. It was really good.
Amazing.
But to use the arms and to pick things up, to open doors, to handle objects, there's still a lot of open questions there in terms of the software. It will take time. Maybe there is no blockers at this point.
Right.
There's no big question marks. There's nothing that we see in the near future where we go, well, we don't really know how to do it, which is great news because a few years ago there was. And now it's all about putting in the time, the effort, and it will take some time and effort, but we see a path to make these robots useful in an autonomous way.
What were those biggest challenges? So a couple of years ago, when you were looking down a path and thinking, shit, we've got some big hurdles here. What were they?
Well, if you have been following kind of some of the robotics challenges initially, when these very expensive robots keep falling over, um, locomotion just wasn't working in such a robust way.
Right.
Robots couldn't get around, and that's a main blocker. And what happened in this space is reinforcement learning, which has been around for a long time, so it's nothing new, but the way people are using it is new, and the simulation environments that are available now are new,
Right.
which means we can simulate thousands upon thousands of different motions in the virtual world and train a model like that will have quite good performance on the real hardware.
How big an impact has AI had on expediting the progress?
So reinforcement learning is a branch of AI.
Yes.
So for sure it was a crucial part of this journey. And the same with LLMs. I think large language models will play a very important role in robotics and what we can do. They are not the full picture, but they will be a very important part of the system that we will end up with.
What part do you think they'll play?
Well, large language models are very good at containing general knowledge of the world.
Yeah.
So contextual information, like if you ask, if you interrogate a large language model about objects in the real world, they likely give you very good replies about what those are and how to use them, how to open a water bottle, that food is in the fridge, that a full water bottle is heavier than an empty one. So they contain a lot of knowledge that we can utilize.
Right.
And of course, they are quite good at conversation. So they can provide a way to interact with these systems in a more natural way than currently the touchscreens that we use.
I'm with you. So G1, let's call him Gary.
Gary. Okay.
Gary for today.
Gary for today.
Yeah. So from that perspective, will Gary be powered by... Because you're expecting this guy to have really great speech by the end of May, aren't you?
Yes, it's coming very quickly.
Very quickly, which is going to be absolutely incredible. And if you look at I guess that is actually a pretty non-significant challenge, really. It's probably the integration of it, because the technology is already there, isn't it? The kind of speech to text, text to speech, and all that stuff, and integrating it into an LLM. So that seems pretty non-significant. But the bit where I'm thinking about is, will the LLMs end up being part of the decisioning engine that is driving this technology?
So it's a very good question. I think there will be part of the decision process,
right,
but they won't be driving the decision process.
Okay.
I think the planning phase of a robot, like get me a sandwich. Okay, the LLM might know that to get a sandwich, the kitchen is the location where it needs to go.
Yes.
It will know that the sandwich is probably some ingredients between two pieces of bread. So it has all this knowledge. But to do kind of an accurate step-by-step plan, I mean, we are seeing advances in like agentic models, but I still feel that there's room for traditional planning and control-based software in the middle there as well. So I think it will be a hybrid solution. But people have different opinions on this, and there are some different approaches.
Do you know what? I read something last night. I was going through it, which is really fascinating. Is that they say that ChatGPT is using its internal models, which are far more advanced than the ones that they're releasing externally, to lead the research on their own models and their own capabilities. So actually what we're seeing is something which they might have been using internally 9 months ago to pioneer what their next phase of development, which I found really fascinating. The curve continues to incline with LLMs, and then we're seeing the integration of memory, and then the contextual training, spatial training, imagery, video. It's becoming, I mean, look, the biggest issue with video is the kind of latency and processing speeds of it. And I guess that would then apply to real time in some respects with LLMs and lots of technical challenges. But I just wonder whether how much of that will become autonomous when the LLMs become autonomous. Do you know what I mean? Like, is there not symmetry with the growth of the humanoids and the LLMs?
For sure. I mean, we are utilizing LLMs as an important tool that our developers use to make software quicker.
Yes.
So we're already seeing efficiency benefits. They are not at the point where we rely on them fully, but they are a very useful tool. And there's certainly a chance that if the capabilities grow quite rapidly, that all these timelines get much quicker than people expect.
Yes.
Now with humanoid robots and robots in general, we don't have robots building the robots yet. We have people building robots. It will be interesting if we can accelerate it. Imagine humanoid robots building other humanoid robots.
Yes.
Then we can see that exponential growth in availability and affordability of the technology. But an interesting part that you mentioned there with LLMs, that they are gaining better and better memory. That is true, but in some ways that is still an illusion on how they gaining that memory from experiences, from conversations. And that's where there is currently a big gap in both AI, but especially robotics, if we need to start using these. The lifetime of these systems in terms of the software operation is hours. You turn on, you do some tasks, you reset. The robot goes back to square one and does it again. So minutes to hours is kind of the operational life. What we don't have yet, and what I think would be very interesting in the future, is to extend that operational life of the robot. So what we call long time horizon tasks. So this robot is living at the factory for a month, living in your home for a month. How does it deal with the time duration? Can it utilize the experiences, the learning, and improve at doing those tasks? And that's not part of the current LLM journey, I feel.
Yes. Yeah, that's interesting you say that. So when you talk about that memory, it's not really a neural memory, is it? It's more of a kind of, it's more silicon based rather than carbon based, basically.
Yes,
right now.
For sure.
So that whole paradigm really needs to shift in order to bridge the gap from humanoid to human. That gap narrows.
I mean, imagine having a robot in your house and it's maybe doing some useful work, doing your laundry, doing the washing up, doing the cleaning and tidying. Fantastic device. But every day when it starts up, it's reset. It has no knowledge of the past. It has no prediction of the future. It just gets up, does the chores, and then reset next day. It starts from zero again.
And that's a tremendous amount of memory that's required to consume all the things that we consume. 360 degrees of multiple senses, the combination of those senses, and then processing and storing that, and then having that on real-time access into a kind of completely unified.
But we are working on some of these questions on how we can make that more efficient. The human mind is incredible at making this information storage very efficient. Your brain discards the details that you don't need to know. So when you go back in memory, you remember some parts really vividly that were important for that time, and some other parts, like who was in the background or what picture was on the wall, these details are lost because your brain discarded those parts. And our brain is incredibly good at filling in the gaps. So maybe you do remember some picture on the wall and your brain even paints the picture. It's not the correct one. it's another memory that your brain filled in to complete that picture. So it works in very interesting ways in say data compression and memory already in the biological part. So
and often that memory is there, but we're not able to access it, and it needs someone else to poke and prod around and provoke that thought to fill the gaps. And so it's incredibly deep and detailed, and
it's incredibly efficient as well.
Efficient. And so that's where we are today. So we're remote. We're moving fast. What do you predict? What next 1 year, 3 years, 5 years, 10 years? Talk me through what's the
Yeah.
roadmap?
Yeah. 1 year, we are still similar situation. We will have some incredible demonstrations in the next year. I think people will be really impressed and really interested in what the future brings in the next year.
Right.
But in about 2 years' time, we will start seeing these robots in industrial settings. Factories, warehouses. Well, warehouses we already have robots, but more the smaller scale factories. So rather than the purpose-built large scale facilities, we will have robots accessible by smaller businesses.
Right.
And in those industrial settings, we will start seeing the early adopters in 2 years, and ramping up more and more. People will utilize these tools, which essentially are making businesses more efficient. And that's coming fairly short term.
Right.
Longer term, 5 years, I think we're starting to look at consumers. So people who want a robot in their house to do some of the chores that they don't want to do.
5 years, you think?
5 years for early adopters, yeah.
So my prediction was 5 years, be able to do everything that a human does, more or less. And 10 years, they'll be indistinguishable from us.
Right, right.
How far out am I, do you think?
I think the 5 years household robots won't be able to do everything,
right,
but will be incredibly useful and helpful. So they will be at the point where people think like, oh yeah, I do want to invest in this robot, to pay the price of this robot because it provides me enough benefits to my life that it's worth the money. And my prediction is these kind of consumer robots will be similar to a car. And that's a big range. You can buy an affordable robot. You can buy the Ferrari of robots. There will be a range. But they will be all at the point where people start thinking about, like, that's a useful device. I can see how that helps me with my life, how it allows me to have more free time, how it allows me to focus more on work, whatever people want to do. But won't be able to do everything a human can. So I think your prediction of it can do everything a human can, I would push that back to the 10-year mark.
10 year. Okay. Yeah, interesting.
And the other side,
Yep.
you mentioned same as a person in appearance.
Yes.
I think perhaps that is coming sooner than we think, because it's very easy to convince people that a device is more capable than it actually is. If you put a face to it, if you make it more natural, people will relate and start interacting with it at a much higher level than perhaps the robot can handle. So there's kind of an amazing opportunity, but also a danger there, is that we will attribute much higher skill to these robots in the first few years than what is under the hood. But that's incredible as well, because on occasion people will be able to relate more and work with a robot in a much more comfortable way because of or human nature, that we attribute this human ability to them.
And that's the integration. That's where the real integration comes, right? And so, that's going to pose so many issues or problems. But when you look out on that timeline, let's suggest the 10-year horizon that we've spoken about, is that all the capabilities of a human, indistinguishable from a human. How does life look in your mind, in your vision of the world, when we hit that nirvana state 10 years from now?
I'm always an optimist. And I believe that this is an incredible opportunity for humanity to increase the amount of things we can do. And I know that people are kind of worried about jobs and what will people do. In my mind, that is a worry that we created, and it doesn't have long-term foundation. Maybe on the short term, there will be switches between tasks that people need to do, and I can see how that might be hard for some people. So we need to move quite carefully in this early time. But in long term, I can think of way too many things that we want to do as humanity. So I don't think we are in the danger of running out of things to do. Just to address some of the key problems we have right now, say with the climate, with creating more renewable energy, with producing the technology that we need to tackle this issue and some other issues. We need more work, we need more effort.
Farming, there's loads of significant issues, aren't there?
Absolutely. And all these people we talk to understand that it doesn't mean we will have less farmers. It just means that they are not as overloaded as they currently are. I think we live in a strange world where productivity is higher than ever. We have access to amazing devices that anyone can afford to buy in the shops. Yet everyone somehow feels too busy and too overloaded all the time. I mean, there's some detachment there. Like how can we?
I agree. I absolutely agree with that. And it's funny your view, and I consider myself a tech optimist as well, which people should probably shoot me down for. But I absolutely see the same thing. I talk about it being the delta. I think there's a delta where people will lose jobs faster than new jobs will appear, and that worries me a little bit. But I actually see this is a route personally to the costs and goods of services being reduced so dramatically that they become abundant for people, and actually the standards of living really rise, and that kind of poverty line is diminished significantly.
Well, if we look at it historically, pineapples used to be a luxury item that only the super rich could afford, and it was a status symbol. These days, you can go to any of your local shop, and buy a pineapple at a price that's very affordable for your available resources. So,
absolutely.
It's interesting to think that if everything we have today is super cheap and affordable, what are those future things that will come up that will be the luxury items in the future? Can you save up for a trip to the moon and live in a hotel in the moon? Maybe that will be the luxury item. Yes. Can you have your own robot theme park or virtual reality experience? So all of these might be luxury items that we don't have yet, because it wouldn't be economical with the current technology to create them.
The car market's a really good analogy, isn't it? Because actually, it's the better technology is less affordable, and so that will be exactly where it'd be the same makeup, won't it? So maybe the super rich will be doing time travel and intergalactic movement. But actually, when you think about it, all the increases in propulsion and all of these other technologies that we're talking about, actually travel. I think it's Branson was trying to get to the other side of the from the UK to Australia in 6 hours or something by different. So those types of things become a real reality. Help me visualize it. Do you think that we'll be seeing these guys wandering around autonomously with us kind of 10 years potentially from now? Will I be sending him to the shop to pick up a pint of milk?
Yeah, absolutely. Yeah, I think there will be robots on the streets running errands and chores for people, doing work. So it will be an interesting shift to our life, and how we handle that foot traffic and interactions as well. And people might want robots that do certain jobs. So even again, going back to what is normal now used to be luxury in the future. What is luxury now is to kind of own a business and have your employees. Might be a very affordable reality to a lot of people, because you can purchase several robots and start your business, which can be easier and quicker than trying to do the same thing with the current resources.
Well, I think that's a really incredible point, because what this technology actually does is it levels the playing field globally in terms of accessing manpower. And what's interesting is that China are effectively going to be eliminating their strategic advantage, which is the cost of labor.
Yeah.
And actually, I think that you're right. I see that the future industries will be manufacturing. And I think manufacturing will become absolutely localized over a long period of time, because you'll be able to absolutely lease these guys to do things at an extraordinary low cost. And then the only real cost of the good is the materials and then shipping, distribution.
Yeah.
And so actually this kind of, it's interesting they're pioneering so much, putting so much investment into this space, China. But actually I think strategically, and it's one of the other reasons I think that if you look at the US right now, I think it's really smart what they're doing, because I think that big companies, which can look 10 or 20 years ahead, recognize that. And so this kind of surge where the US have got right now, which is about you need to manufacture in the US, I think a lot of companies are going to expedite that immediately. I think, and we've just seen Apple say that I think they're going to start building their iPhones that they sell to the US in the US. Interesting what they said. They're going to build their iPhones that they sell to the US in the US. And I think that's the future of manufacturing, actually, and assembly. And these guys enable it. I mean, these guys plus the broader kind of robotics outlook. What's your views on this?
It's definitely a part of that in terms of affordability and where goods can be created.
Yeah.
But I would take it in two different directions, actually. One is manufacturing is also an industry that has environmental impact. And you need to balance this protecting your environment with having enough people in locality to work at this place. If we detach the two things and could put manufacturing in places where the environmental aspect is easier to handle, how Tesla built a factory in the middle of the desert where you're not affecting a forest, you're not affecting wildlife. It's quite interesting how we can redistribute of where things are made. Or some of my friends and companies I know are working on also producing things in space, where you're completely removing that environmental impact.
Right.
Can we redistribute some of the manufacturing in these places?
Wow.
And suddenly we have less environmental impact on Earth, so we can have a much nicer place to live in.
What sort of stuff are they looking to manufacture in space?
Initially, they're looking at high-value items that are hard to make on Earth. One example can be fiber optics, but there are several pharmaceuticals and chemical items as well that are easy to manufacture in space and would be economically worthwhile already to do.
Wow, so that's actually building a manufacturing plant like a space station.
Yeah, absolutely.
And the benefits of that is that basically the pollutants, the impact on environment that they're trying to address.
It's suddenly nothing. You also have very affordable power, because once you are over the atmosphere, you can put solar panels on your device, and you have limitless and very affordable power.
How much more powerful is the solar outside of our atmosphere?
Much better.
Is it?
Yeah.
I didn't
a
know
lot
that.
of the solar energy is lost in our atmosphere. So absolutely, once you're in space, these panels have a much higher capacity.
Absolutely. No clouds getting in the way of those bad boys.
Absolutely. And you can put them on an orbit where they see the sun all the time. So no nighttime, no clouds, no atmospheric loss.
Yeah. Yeah, it definitely sees like the bridge between outside and inside orbit is going to be one of the most significant challenges or the most significant, I guess.
Yeah, for sure. And circling back to the manufacturing side, we mentioned kind of the affordability and cost and accessibility of all these goods for everyone. But I think there's also another aspect of it, which is quality. We have been trying to make things cheaper, but again, if we look ahead of what's luxury now, will be affordable by everyone.
Yep.
Imagine if all the clothing you can buy can be completely personalized to you. So you can go to a shop where they take your measurements, your preferences, your history perhaps and create clothing that fits you, that makes you feel good, that benefits you.
But you're not going to the shop. This bad boy here is actually scanning you,
Actually,
isn't
yeah,
it?
the robot can pick it up once it's ready in a couple of days.
Yeah, but it's also going to scan you.
Yeah.
That it's going to have such unbelievable technology via its kind of radar, lidar, all of the any. I mean, I'm not sure what the other technologies are that are being used, but all the stuff that's in a car, I'm well
Yes.
aware of. But
Yes.
that kind of ability to survey.
Yes.
So its ability to survey you and your environment. And so you're right. Yeah, absolutely could get you the perfect set of clothes
And
tailored.
and that data collection is a very interesting point. So right now, this device and actually that's our preference as Autodiscovery is an offline device.
Right.
So you don't need to connect it to the cloud. Everything, even the large language model, we are running on board the device, and that's quite hard at the moment, but already possible. And we see with some advances of compute, it will get better and better. But we are very keen to have the ability for such a device to be completely disconnected and to operate on its own, because we know that people care about privacy and data protection. Even if you don't intend to, as soon as something is connected, you have the chance for someone of interfering it. So why have it connected?
What's the risks to that though? That doesn't that mean if it gets incredibly smart? I mean, that it can then could it override itself at some point and then completely disconnect from the system, become truly autonomous? If it's got the ability to go and charge itself, which would be a very easy physical task.
I think that's my ideal scenario. I mean, if we think about all the bad scenarios with robotics and all the kind of sci-fi that show us a future where bad things happen related to autonomous devices, all of those require the devices to be connected and to operate in kind of the machine time, much faster than humans. Those are the cases where things go bad. If we don't have things connected, or if we manage the connection of when, let's say, a robot learns something important, we do want to copy that skill to other robots, we can do it, but let's do that in human time. Let's not allow the robot to send out that update on its own, but we get it, we inspect it, we upload it to a few test one, and yeah, maybe it takes some months, maybe it takes some years, but we know the integration is safe.
But it's going to be crucial though. I guess when I think about it, that they kind of call it air gap, don't they? I think it's like kind of air gap technology where, but you're right, because that'll be a significant part for if it's not, whilst it's not connected, it's more difficult to then be hacked, I guess.
Yes, yeah. And if it's not connected, then things move at human scale, human speed. If things are moving,
help me understand that. What do you mean by that?
I mean, if the machines are connected, then if a software has some error in it that causes an effect that's not desired, it can spread very quickly. Like we see with some hacks or some errors, the effect can be large scale, global, and immediate. That's the bad side. If things are less connected, more personal, developed in pockets, then they move at the speed of us. And we know that there are good humans and bad humans. We know some people are working on things we don't want, some people are working on things we want, but it's all moving at human speed, which means our society is designed to respond and handle and contain if things are to go wrong. So if we limit things to our speed, then we can provide safety in the way that, okay, something has gone wrong, but we have the time to respond.
Yes. Yeah. And it's just another place, isn't it, where security and governance is going to be absolutely crucial to this. Where are we from a governance perspective? Regulation is the government onto it? Governments?
I think it's a bit behind, and it's always the case. I mean, the government respond to what the technology brings. It's still very early days for the technology. A lot of people are working on this in the UK, so there's some very good initiatives, and I think there will be some good publications coming out of the government. mostly what I would like to see is kind of guidelines of best practices. Because all of us, many different robotics and technology companies, are trying to figure out the way to do things. So if there is some guidance on, okay, we think that this is the proper way to do it,
Right.
I think that's incredibly helpful. But we shouldn't yet force people down that route, because we are still at the point where there might be innovations coming out of places which we don't expect.
Yes.
So best practices would be incredibly helpful. I think the regulations can be responsive. So
Yeah.
wait until the devices are deployed and then respond to the actual need of people.
What are the things that worry you most about the scale and speed and the impact that these guys are going to have?
I think in my mind is that we are not moving fast enough. I, Again, my vision is quite positive, and I think we could benefit hugely out of robots.
Yes.
Everyone, when we say we, our goal would be to benefit society, so every layer of society. Um, and right now, the danger is that we suddenly are up against the clock, because robots got a lot of attention and they got very popular, and we have a time window to start producing robots that are useful, that are doing some tasks that people understand that they are beneficial.
Right.
And if we don't do that quick enough, then we have the danger of people discarding this technology, saying, oh yeah, they promised us all this, but it hasn't happened yet.
Yeah.
And maybe it's 2 more years, maybe it's 5 more years, but people are less understanding of that kind of delay.
But what societal risks do you see with it? You know?
I think there's definitely a risk on how people will respond to these devices. We can get quite attached to autonomous things. So we already experiencing some challenges in our society related to technology and social media, of people getting isolated or not interacting with other people the way we used to, and having the ability to automate parts of your life might enhance that, and takes us even more apart. But there is also the potential that it could potentially free up people to spend more time with their loved ones and families, and meet new groups, and have more time for the social interaction. So,
but we spoke about that earlier, didn't we?
hard.
This whole concept of the fact that it's got this level of intelligence. It's almost like that, like I said, phantom limb issue, where you kind of just, your perception or your mental perception is difficult to what you visually perceive. And so that connection, they're all saying please and thank you and okay, thanks, see you later to ChatGPT, as because we respect its intelligence. Its intelligence mimics human interaction.
Yeah.
And I think you're right. I put something out the other day where I'm talking about how I think this really, well, the collapse of the population is a real issue. And I can't help but think that, particularly when they become indistinguishable to human beings, that for as companions, they're going to be incredible. And I talk about this thing about human connection. Everyone's like, you'll never replace human connection. I'm telling you what, intelligent connection's much, much better. What's that? What is that? That's like infinite listening, incredible intelligent perspectives, broad objective perspectives, a wealth of knowledge to share, compassion, empathy, all stuff that can be easily mimicked with these models. And then you start to put that into, you start to bridge that gap, because we're already saying please and thank you to something we can't see. Then you can see it and it start to build that. Then all of a sudden that, I'm just wondering how rapid those emotional attachments come. And you've already said you would definitely become attached to some of the models or bots that you've built previously, right?
Yeah. And those were clearly unintelligent, unconscious machines, but you still develop this attachment, and there are stories already with similar devices being used in the armed forces, and in industry, where people get attached to these devices because the device saves their life, or provides benefit, keep their friends safe, saves the factory so they don't lose their job. So it's already happening, and I am preparing a talk which will be ready in a month time, about consciousness, because I think there is a separation here with two completely undefined areas of intelligence and consciousness.
Right.
But we somehow still have a human understanding of what these mean. And we can say if an object is conscious or less conscious or not conscious.
Right.
And I think it's a spectrum, but it's a very interesting area to start talking about in a bit more detail, because I think it's a neglected part of research, a neglected part of conversation. But we all know that a rock is not conscious, and we are very happy to mine minerals and to use them to build devices. We have I don't think anyone has issue with that.
Nope.
We are quite happy eating plants. We know that they are alive, but we know, well, we think that they are not conscious. And again, most people are quite okay with producing and eating plants. We feel a bit more conflicted about animals. So again, we know that they're alive. And I think if you ask people, more people will say, oh yeah, an animal is conscious. Definitely people who have pets and dogs and interact with them will say absolutely conscious. But as a society, we're still accepting at using animals for food production. And then we can get to the kind of higher level of consciousness of primates and then humans, where we are like, oh, these are absolutely conscious, and we have higher level of protection of what you're allowed to do, and how to protect this consciousness. And my the thing I'm a little bit afraid about is that perhaps we will start attributing higher level of consciousness to these machines in the early days than what they actually possess. And I know people are already talking about robot rights and are robots going to vote? And I think for these kind of conversations, it's way too early, if they ever will come up.
How do you define consciousness?
It's a good question. I think it's hard to define as a concept. I don't think we have a robust definition for it yet. And that's why I gave the example of scale.
Yes.
When we identify a few objects, we can compare them. And I don't think it's a on and off. I don't think it's a rock not conscious, human conscious. I think there's a lot of in-betweens.
Yep.
When we look at, say, a chicken, and we look at a dog, and if you ask people which one is more conscious, I think people will point at the dog and saying there's something more going on there. We can't define, we can't describe, but in terms of general agreement, I think we will attribute higher level of consciousness to certain things. And when we go down to like bacteria and plants and mushrooms, okay, it's alive, but it's not conscious.
Yes.
So I think it's a topic that we need to explore much more. I think it has been neglected, and it needs some discussion.
I guess when you think about it from the lens that you're worried about it on, I guess self-awareness is a big part of it, actually, consciousness, because the more self-aware something is, the more, I guess, it's considering how it feels. Yes. And at that point, as that scale increases, it feels like I should be also taking into consideration their thoughts, feelings, and emotions. Maybe consciousness, one way of kind of considering that is via self-awareness. Things which have zero self-awareness, a rock, we have no problem with. That's a very good point. And that's kind of the source of my worry, is that AI and robots are incredibly good at faking self-awareness. If you have more in-depth understanding on what is going on in the model, you know that it doesn't actually have the type of understanding that it displays. Yeah. But if you're talking to an AI model now,
they will have a degree of self-awareness. They know that they are an AI model. They know that they're living the computer. They know that you are a human. They have so much of this knowledge that previously we attribute to human level self-awareness,
Yeah.
but is, say, completely faked at this point, and
Yeah.
will be in the near to medium future.
Wow. Yes. And I think that makes sense, right? The fact that when something knows that it can it should be caring for itself, then you should care for it also, I guess, in some degree. Talk to me about what's your view on kind of the impact of third-party aggressors, criminal actors, terrorists, hackers, that kind of, are we just creating a set of tools for these aggressors and activists and, terrorists to be able to inflict harm, do you think?
Unfortunately, I think that's unavoidable to a degree, but it is also something that has happened in the past. We create weapons that are now available. People can buy a gun in many countries. Just vehicles, unfortunately, can be used as a weapon of war or terror, as we've just seen. Those are incredibly beneficial devices for a society, but in the wrong hands, they can be used the wrong way. So, unfortunately, it is something that we need to be aware of. And it comes back to the part where we need to, of course, have the suitable protections and do as much as we can to prevent something bad from happening. But in the absolute worst case, where something bad happens, make sure that our technology is structured in a way that any impact is limited to locality, limited to human speeds, so we can respond to it, so our emergency services can respond to it, and also to start integrating these technologies in our defensive force. So, maybe hackers hijack a robot, but the defensive robot can respond to it much quicker and be there and have the ability to stop this other robot. So we need to build up our defenses as well.
It's interesting. I think technology, probably nuclear, is the only one I can think of as a real exception. The rate of their ability to secure themselves has matched the rate of their ability to innovate. The rapid rise of AI, actually what comes with that is actually the ability to research and find groundbreaking security protocols just as much as it does to how to deploy a humanoid. And so it's kind of has this unbelievably canny way of kind of answering its own questions. And it's funny because when I looked at AI originally, and I remember some people posting about, it's always going to hallucinate and energy is going to be an issue. And I look at those and I think, do you know what? Those just feel such insurmountable issues and it's all about the benefit, isn't it? If the benefit is so significant, then the investment will follow to address the challenges. And these guys, Gary and his mates here, has the ability to completely transform the world. And so I can't begin to think that we won't then find the security protocols to maintain them.
Yeah, absolutely right. And I think that the way is to give these tools to the good guys. Make sure that we are ahead of the curve, that these devices are available and accessible to the people who might respond to these scenarios. And it is a difficult question on how do we decide which tools to use, and it comes back to the mission of Autodiscovery. I think we want to make these devices accessible for everyone, and I think that's very important, that anyone can be owner and operator of these devices. And I think the scenarios which can pose real danger to our society is where a very select few are in control of 90% or the majority of these devices, because then things can happen quickly and happen in a catastrophic way. If you have hundreds of different robotics companies all with their own product competing, in a strong way. I'm trying to beat the other robotic companies because I think my product is better.
Yep.
We continuously compete, and we both have devices in the emergency services that can respond to a scenario.
Yep.
That's great because we keep each other in check.
Yeah, and if anyone wants to know what the opportunities will be that come off of this, where employment will be, it will absolutely be in security and in compliance, and the whole ecosystem, I think, that comes off the back of this new wave of technologies that we're creating and powering, robotics and LLMs with. It's really, really fascinating.
It's going to be an interesting journey in the next few years.
It is. Mate, well, thank you for coming along. It's been unbelievable talking to you about it. I could sit here for another 4 hours going through everything else, but I know you've got some robots to deliver, which is great. So thank you for bringing Gary. And just to wrap up, anyone that's watching this, who should be reaching out to you at Autodiscovery? What types of customers, what types of people? How can you help? What people can you help today?
We are very interested in talking to kind of small and medium businesses who traditionally didn't think that automation suits their environment, because I think we are now at the point where it can really benefit them. They need to understand it's still quite early days. So we want those people who are willing to take a leap, willing to take a little bit of risk and work with us, but then hopefully reap the rewards. If people are more cautious about this, then wait, a year or two, but keep it on the horizon.
Yes.
And we are super interested in talking to these kind of small, medium businesses to help make them more efficient, to help them stay competitive in the current world environment, to keep the jobs that they already have and perhaps even grow. And I think automation needs to play a part in that.
Yeah. And one of the things that I think you mentioned earlier, which is really interesting, is that if this isn't in your industry right now, then you could actually be the guy that invests and builds and deploys a fit-for-purpose solution for that industry. If you get involved with you now, and reach out and can solve that problem, not only for yourselves, but then license or resell or whatever, that operating system that you've created back into that industry.
Absolutely.
So there's a big opportunity right now commercially.
We're very happy to support other technology businesses as well, to create these new specialist devices for a specific sector. And there's quite a few out there. I think collaboration is key. The market is huge. The opportunity is there. It's time for people to get involved and to do these things.
Amazing. Well, thank you for coming along. Thank you, Gary. Awesome. You'll have to come again, mate. Yeah, thank you, Aron. A real pleasure.
Thank you.
Great to spend some time with you.